Hi, everyone. Thank you for joining us today for Career Conversations Working as an SRE. Before I introduce our speakers, I have a few quick things to go over. Please take a moment to read our code of conduct. We ask that you be kind and respectful to everyone, including our speakers. We want the reactors to be a place everyone feels welcome. Please ask your questions using the live YouTube chat. If you haven't already, please check in using our event check-in at aka.ms/reactor-check-in with event ID 15009. In the chat, I will also be sharing some links to our Reactor meetup page and monthly newsletter if you're interested in checking out what other sessions we have coming up. Today's session will be added to our Reactor YouTube page in 24 to 48 hours. And finally, near the end, we'll be sharing our Reactor survey. If you have a few minutes, we greatly appreciate your feedback. And I am now going to pass it over to John and Sam.
All right. Hello, everybody. I'm a regional cloud advocate here at Microsoft, trying to help empower people to build awesome things with Azure. And we are currently having this new series called Career Conversations, where we're talking with different people in different roles throughout Microsoft and just the tech career spectrum to figure out what they do and why that's so cool. So today I'm speaking with John Stupka, who is an amazing person and a site reliability engineer with Azure. And so we are going to be learning a little bit more about what that actually means and what that role entails and why you might want to do that. So welcome, John. And can you tell us a little bit just about what site reliability engineering is?
Yeah. So my name is John. Like Sam said, I'm a senior software engineer who specializes in site reliability with Microsoft. And yeah, what is an SRE? So an SRE is a site reliability engineer. There's someone who focuses specifically on the reliability of systems, whether through automation, analysis, or expertise that they have within systems. I think Microsoft defines SRE as an engineering discipline devoted to sustainably achieving at the appropriate level of reliability in systems and services and products. I mean, that kind of boils down to, systems will have issues and systems will have failures. What is an acceptable amount of failure for someone to have? And SREs kind of identify that and try to reach that goal for the application.
Awesome. So we've talked a little bit about this before, and one of the things that I always had, like the misconception I think I had when we were talking about SREs is SREs are the people who fix things that break, and that's not quite true. You mentioned like mitigating and reducing that error percentage. How does that work? How do you anticipate that and work towards that?
Yeah. So like, a lot of people think of it as we're in a pager and there's something that's wrong with service and you get paged and you have to fix it. Like you're in charge of fixing the servers, restarting them, and whatnot. So with site reliability engineering, it isn't just wearing a pager. You do wear a pager and you are on an on-call process, as that's the best way to understand the failure scenarios of an application. But as a site reliability engineer, you want to automate yourself out of a job. So you want to identify those failure scenarios. You want to identify common failure scenarios, whether through fault analysis, through postmortems, and basically through like monitoring your metrics and using observability. But you want to identify the common failure scenarios and then engineer solutions and peripheral systems to remediate those automatically. You having to interact with the system and fix things after the fact is actually, you didn't do your job right. You are not reaching your reliability goals. And that's what a site reliability engineer wants to get to. They want to get to that point where you go home and watch Netflix all day, and you don't have to worry about interacting with the system. That is what a site reliability engineer does.
Awesome. That makes a lot more sense. It seemed very, very hectic and chaotic if you're just waiting for things to fail and then trying to fix them. So how does that translate into your normal day-to-day work? What do you do in a normal day?
So my team on a day-to-day basis and me individually, I split my time kind of 50-50 between engineering different systems and then helping my team to engineer solutions to the things that we've identified, analyzing the data that's coming out of the system, and basically taking the time to work with our partner team. I'm in what we refer to as a SRE engagement team. So we work with a partner team, mine being Azure Kubernetes Service, and we interact directly with that product team. We're in an on-call rotation with them. We're working on their microservices to basically do pre, post, and during deployment validation and analysis. And all of that kind of boils down to, we have this very large service that's used across lots of different regions. It's highly available in all these different regions and has a lot of components. All of those need to interact together correctly in order for them to have a high availability. So we write automated systems to analyze how those are all interacting. And then from that analysis, propagate the information up towards different services that we've written that handle release gating on top of the services, that handle automated alerting on top of the services, and that handle basically like different forms of rollout, whether it be canary, A/B, or automatic rollback.
Can you talk a little bit about those release patterns? Like I've done a few sessions talking about CI/CD and deploying services so that you get your code out into production as soon as possible and have the smallest delta of change when you're making a change. And part of the motivation for that is that you avoid this issue with reliability where you're making large scale changes where it's hard to tell what's breaking. How do you build a system that can adapt to that and can kind of avoid those kind of issues?
Yeah. So with what you just said with like CI/CD, I mean, there's these different forms of deployments that are used, and it all depends on what time you're deploying, the type of thing that you're deploying, and how the different components within that system interact. So like with a canary deployment is kind of like if you take a bucket and poke a hole in the bottom of it. You kind of drip the water out slowly, you release the application slowly to a region until it fills up that region. A/B deployment would be, we have one bucket filled with water and we have a second bucket filled with water, and we just kind of switch out the buckets that you're using. That would be this type of like A/B deployment where one is on and then you immediately switch over to the other. I would say one of the largest accepted patterns currently due to Kubernetes is this kind of A/B style, this green-blue style deployment, where you've got a deployment that's going out, you're releasing it with these health and readiness endpoints, and then as one of them comes up, the other one goes down, and we start to direct traffic to the other service that's coming up. Whereas canary deployment is a little bit more difficult to implement because it is this very slow and kind of monotonous process. So it's a very long, trying to think of the word here. It's a very long-term process. It's a very long request process. So you have essentially a system that has to watch things for a very long period of time without having any disconnections, without having anything cause a hiccup in that process. The benefit to both this A/B green-blue deployment and the canary style deployment is, with a canary style deployment, if you have an incident or an issue, you will see it in a smaller grouping of your customer base or your users. Whereas with this green-blue deployment, it is a little bit more instantaneous. On top of that, with canary deployments, if you release it with a system that has a lot less requests than you're expecting, or like you release it at a time when there's a lot less requests, there's a chance that you may not pick up on that slow failure as quickly as you thought with this slow deployment process. So you want to release a canary deployment in a region or in a time where you're going to have enough requests per second where you may be able to actually determine whether or not there is a failure. And there are ways where you can actually kind of artificially create traffic to help you better understand that. That's one of the things that actually my team works on, which is a service that runs automated tests on a schedule that we'd like and allows for our partner team to do that in a customized way. But that's what I'm talking about when I talk about canary deployments and A/B green-blue deployments.
So I think you're kind of alluding to this a little bit, but it almost sounds like you're testing in prod. You're pushing messages and running tests against production instances to make sure that production is actually doing what you think it should be, even with not necessarily real customer data. Is that accurate?
Yes. So if you're not testing in production, you're not testing. You can test with unit tests, you can test with integration tests, you can test with end-to-end tests, you can test in stage, you can test in your dev environment if you've got that, your perf, whatever. But when it comes right down to it, if you're not testing to ensure the stability of a system that's in production, and you have dependencies of any type, whether it be networking, database as a service, your VM that you're running on, all of those different systems make up one larger system, and any of those pieces can fail at any time. I think one of the best ways to describe it is any large complex system is in a constant state of failure. So you need to be on guard, you need to be aware of these possible failure scenarios. And that's where a lot of this real-time test running comes in handy, because you aren't just putting something out and hoping that it works at that point in time. You're validating over time, and you're validating constantly that everything is working, everything is good. And SRE wants to automate the process of, if something goes bad, or if we detect an issue with this, how can we automatically remediate that so that we don't have to interact with it? How can we let the machines take care of this so we don't have to?
Does this tie into there's a whole, I guess, slew of different things that this kind of features, but I'm familiar with things like chaos engineering, for example, where you start injecting failure states intentionally into systems so that you can have predictable failures rather than just suddenly things fail at 2 a.m. in the morning and everybody wants to be in bed. Is that similar to is that sort of similar to like the tools that you're using?
Yes, we do have a project that is related to chaos engineering. It is related also to that test running service that I was speaking about, where chaos engineering is used to better determine when we do have a failure, or where we've already identified a possible failure scenario. What happens when that goes down? What happens when you remove the networking from major data source components? What happens when you slow down the network on certain things? What happens when you don't fully go down, but you have partial outages, like brownout failures, as people like to say? And that's super, super useful. I think, like, when it comes down to it and how people end up testing as they go, you start out with like these unit integration end-to-end tests, and that's the first step. And then you start getting out into the regions. If you've ever worked in retail, you know for a fact that Black Friday, you need to be ready for a large amount of requests. So that's like the first thing that you do. You go, okay, how many requests am I seeing? How much load can I handle? And if I lose certain instances, or if I have certain issues, do I have enough in a different region so that I can fail over? The next layer to a lot of this is that chaos engineering scenario where they actually do lose that region, and they do it on purpose in order to see if their hypothesis or their testing about performance was correct.
Okay, that makes a lot of sense. I actually kind of wanted to. So I've tried this testing in production. It's hard. There's a lot of things that you have to do to make sure that it's actually working, and you don't just break production. Do you have an approach that works really well for getting started, kind of implementing these production targeted tests, and kind of how you would maybe consider or look at that kind of problem space?
Yeah, there's a couple different ways to do it. And then there's also some hypothetical things that I haven't done that I know people have done. One of those is basically having a clone replica of all the requests that are going to your service. You basically put some sort of a buffer between your prod service that accepts the requests that you're seeing. Once it accepts those requests as kind of a buffered service, it clones those requests to two separate production instances. One that is your actual production data, the other that is kind of like a replica production data. In doing so, you tend to see what happens with both of these things. So then if you update that system that is kind of your clone system, you can see in real time how it actually would affect things. So if you didn't actually test anything, if you're just running blind here and you want to actually test with your customer requests, put a buffer server in front of your service that accepts these requests, whether it be Kafka, RabbitMQ, I don't know, any type of queuing or message busing service. And if you're using Kafka, please look up log2shell if you don't know what that is, because it's a big issue. But yeah, so buffer all those requests and then kind of split it out between the two cloned services, the one being your actual prod, the one being your test prod, and make changes to that one. And that way you can see what would actually happen to that production service without actually impacting your production service. Another way to do this is that canary style deployment where you have kind of that similar cloned approach where like it's just a single service. So if you have any issues during this canary deployment, it's a smaller subset impact versus like a quick switch between different services. That's also a great way to test in production ahead of time. That's if you can't do, for whatever reason, that like cloning technique of the requests and things. And then the final way that you can do this is just running a test scenario in your production environment to determine whether or not things are succeeding, or running some form of manual test if you have no automation in place.
We've talked a little bit about like failure states, and a lot of them seem to imply like losing production, like losing an entire service or losing some entire cluster or something like that. What happened? It seems like there's another scenario where it's broken for a subset of users, where some specific use case is not working. Is there a way to go about detecting that, to kind of start isolating these errors rather than looking for this metric has significantly gone down? Is there another way to find those? Or
yeah, so a lot of this is what's probably like the most it's the hottest topic in SRE at the moment, which is, you're using something called a SLI, a service level indicator, meaning metrics, logging, etc., and you're trying to achieve a service level objective, an SLO. Using SLIs in combination, meaning you kind of make like a compound SLI. So like you use multiple signals to create a single signal that then you apply to an SLO, will help you to identify larger failures within the system. So if you see the occasional like, 500 requests from your service because something times out or whatever, or you're switching on and rolling out, like that's to be expected. So that's okay, and we have a limit for that. But let's say that you have a combination of failures. Let's say that you have 500 requests coming from your front end, and then you have let's say timeout requests coming from your database. Combining those signals to better give you a larger impact, a larger signal, in order to detect smaller failures. That's a process that people are using now in order to better identify smaller failures, brownouts as they were, within systems, especially within larger systems. On top of that, there's a lot of work that's going into AI analysis and basically time series analysis to detect failures based off of statistical metrics. Again, that's really cool, and that's basically taking what SRE is doing and applying it to an automated processes, which is what we want.
I am brand new to that AI thing. That's something I've never heard about before. I did want to talk a little bit about SLOs and SLIs quickly, because every time I've tried to set those up around projects, it's always really hard to pick those metrics, to figure out what to focus on and where to prioritize and how to measure those things. Do you have any advice or guidance there that you've kind of picked up? Or
yeah, so the basic guidance, like the bare minimum guidance, is to basically set up SLOs for your SLIs on the golden signals, which is something that the Site Reliability book, the Google SRE book, talks about. Niall Murphy, who was one of the people that worked on the SRE book, who was at Google and then came to Microsoft, I got to meet him at a dinner party once, and he was explaining to me, like, it's more of an aspirational goal. We didn't really implement too much of this, but this is what we would have done. But it is really good as like a baseline. And it really depends on the type of service that you're running. A lot of people run these request response services, like an API or something. I mean, even if you're running like a front end with a request API in the back end, it's a request response system. Other times you'll be running something that's like a long-term request system to like a queue. So like you have like Rabbit, Kafka, etc., where you've got something that needs to connect to it for a long period of time, and there's a chance that something could time out or disconnect. And then the third type of service would be a constant running service that you need to detect a failure on, something like a virtual machine or a Kubernetes cluster if you were providing that to someone. And those golden signals are great, but you need to solidify from those golden signals what you can get out of those services and those styles of services that you're running. The golden signals are great for this request response kind of a thing. They do a wonderful job. But when you start to get into some of those more complex systems where it's like the long-term connection to something, or it's a constantly running service, they don't give you as much information as you would like because you're not seeing as many requests. I mean, when you think about it, like a lot of people do request a lot of VMs all the time, but I mean, you're looking at a small company, like they might request a couple of VMs and like hold on to those for a prolonged period of time. They're not going to be requesting and removing constantly. So you don't get the style of signals that you would like out of those. So those golden signals that they tell you to look at are more focused on that request response. I've found that doing those kind of compound SLOs, where it's multiple SLIs to create a better signal, tend to give you more information. And I mean, you can basically take these and apply a dynamic like matrix to them to like combine them in all possible combinations in order to identify the highest signal SLOs that you can find. And from there, start to apply monitors on top of those. But that's the preferred approach, is those golden signals. But I personally, in my experience, it works for certain services, but not others. I'd say the majority of services are these request response. So like use those golden signals as your baseline and then start to expand from there. But those compound signals are pretty great as well. Yeah.
Awesome. I appreciate the background on that, because metrics are hard. You did mention monitors. Is that just a term for something that is monitoring those metrics, or is that a specific thing?
Yeah, it's just a simple service that is watching and analyzing that signal in order to identify whether or not there is a failure.
Okay. I kind of want to pivot into like technologies that you use on a day-to-day. Are there specific things that you tend to find that you work with, or that you would expect an SRE, somebody moving into this kind of career path, to work with more than maybe other engineers might?
Yeah, that's a good question. I mean, me personally, like I'm probably a little bit different from most of Microsoft. I'm using Go, Kubernetes, Docker, Linux, and a lot of like open source technologies and cloud native engineering kind of stuff. But I mean, when I have to think about like the technologies that you as an SRE should be familiar with, or you as an SRE want to get involved with in order to understand kind of like the work that you're doing and get this expertise, I'd say it boils down to like, you want to understand a lot of different stuff. You're not looking for this deep understanding of one single thing. You're looking for a large breadth of information. You want to know how DNS works. You want to know how storage works. You want to know how data center stacks are configured. You want to know how applications handle key vaulting. You want to know how authentication happens from a load balancer where it needs to move you to the authentication service and hand back the cookie or the JWT or whatever to get to it. You want to have a large breadth of information if you're an SRE, because you want to be able to understand all of the possible failure scenarios within that system. As for like specific tooling that you might be exposed to, I think gating technology is pretty important. Finding ways to limit or slow the release of an application to an environment by basically interacting with a CI/CD or an automation pipeline. Automated MDHA principles, things like identifying whether or not a service is multi-data center and highly available, and being able to analyze and determine whether or not that's happening and then remediate it. Grid deployment systems is something that you might get exposed to, which is if you have a large number of microservices, which microservices were all the hotness like 5-6 years ago, and they're probably still all the hotness now, but I don't know. But knowing how to deploy those in a grid style system that can validate each one of the components interacts with each other correctly and then releases forward into the next environment or region is pretty critical. And then a lot of this advanced detection with SLO, SLI, statistical analysis using like regression path and everything like that, that is pretty critical.
I've been taking notes, and I have a whole bunch of things I want to loop back on, because that was awesome. So a lot of what you've been talking about seems very similar to some of my experiences working with release engineers, who work on those things like gating deployments and CI/CD and figuring out how do we get to that final step into production and get developed code, working features into an environment that is working. Is there a pretty close collaboration in a lot of those working environments?
Yeah. Yes. Having and like a lot of people have said this, and I think it's very true. Having a good release engineer is worth its weight in gold, because that release engineer knows all of the different components. They can track and follow the shifting pieces of the system and better identify failures. They're like the Papa Site Reliability Engineer, and we're all just babies. That is the person that you kind of like interact with the most, where you're like, hey, I think I found something. We need to get you involved in this, and we're pretty aware of this issue. We've got some systems that are working on it, but like, what do you think?
Awesome. Yeah, it seems like there's I guess this is a weird thing. That from my perspective, I'm working in both like application teams where you're actually developing an application and infrastructure teams. There's a very big difference, and SRE seems much more in that infrastructure side where you're working not so much on a product, but on an objective, where in this case it's reliability. And that's kind of spans an entire organization or an entire corporation. How do you focus on that? Like for me, one of the hardest things with that is you didn't have that one like keystone, that one light to follow and be like, we're going to get here, because there isn't always that defined path. And so sometimes you got to have to find your own way to wherever you're going. Do you enjoy that, or is there some way that you enjoy kind of taking that in your own direction and figuring out how to steer it?
I personally am kind of like a tinkerer, and I like to understand. So like I'm a learner. So for me, it's actually super, super cool, because I mean, you come into a team and you're expected to help them identify reliability concerns. You don't know anything about that stack. You don't get onboarded with them directly, but you have access to all of their onboarding documentation. But you also get to communicate with all of them and go, hey, what's the thing that keeps you up at night? What's the thing that bothers you? What's the thing that's your concern? And collect all that information and start to identify patterns from that. And from that, you may start to go, okay, we've identified some common issues that everyone's described to us. Let's validate that against what we see as the architecture of the service, or what we see as like the patterns that are used across all the different services as a whole. So I personally did some basically reverse engineering, where I took all the binaries of the system, rebuild them, and identified a architecture diagram from that without any interaction with the product team. And that was on purpose and purposefully, because I wanted to see what I saw directly and then compare it to what they told me as a way to identify whether or not there were gaps that people weren't aware of or not, which is a really cool thing to do, because you start to identify all of this stuff and you start to find all of these things. And it's kind of like your Hercule Poirot, the guy from Murder on the Orient, like you feel like a detective trying to find the possible issues in the systems, trying to identify all the possible scenarios. And then from all of that, you start to build things that help with the patterns that you've identified. Example like what you said, Sam, where like you've worked with the application teams a lot. Like with a lot of applications, there are things that you can do internally in the application to assist with reliability. I know like a common thing that people run into is they've got a secret and they're using a secret to connect to some sort of remote thing. And when they change out that secret, they either need to make a brand new secret and deploy the entire service, or they need to basically go down for a period of time as they switch out that secret. There are things that you can do internally in your application to handle two secrets at once in order to automatically hot swap, basically like a cold hot swap between those secrets in order to interact with things. That's an internal application change that assists with reliability. So although we can identify a lot of these system-to-system architectural patterns that are causing reliability concerns, you can also identify internal application concerns that would impact reliability.
Well, I think this also ties a little bit into some of the experiences as an app dev is you are building these services and you have a product that you're trying to deliver. And that is that's what you're aiming for. And so that can actually make it difficult to focus on reliability and make it difficult to focus on some of that technical debt that you had to take out in order to deliver that product and meet those deadlines. And so one of the, I guess, cool things about working on like an infrastructure team or working as an SRE is it seems like you have time to focus on and actually deliver those things as you want them to, not just in the hour or whatever that you have to actually just kind of tinker with and try to make it as reliable as possible.
Yeah, you're not rushing out to get a feature out, although you are working on peripheral systems most of the time to assist with the teams, but your focus is specifically on the larger impact problems. How can we take these larger impact problems that are causing disruptions to service or causing possible outages, and how can we, at a larger scale, apply a fix to that? Think about it like a principal engineer who's expected to work with an organization and identify larger issues across the organization and then create a solution for all of those engineers. A lot of times they make like a framework to help you build your apps quicker and faster. It's the same thing with SRE. We're analyzing that application to identify patterns and problems and then creating solutions for those problems. You
actually brought up like software engineering levels and roles. I'm curious, as an SRE, what is the difference between an SRE, a senior SRE, and then moving further up the stack into a principal role or a higher level role? How does your role change throughout that career progression?
So my team is like, I think it changed now, so I'm probably going to be wrong. It's an SE, an SE2, myself, and then we had someone switch off like 3 months ago. But basically, at this higher level of SRE, you're expected to interact a lot more with your engagement team. You're expected to do a lot more outreach and communication with them, be a lot more active in any possible incidents that they're dealing with, to have more knowledge about how there's different failure scenarios. At those lower levels of SRE, you're a little bit more focused on building these peripheral systems and kind of implementing these changes. And at that higher level, you're doing a lot more to find those patterns, and you're doing a lot more to identify those patterns in order to either give that to your team to help build those peripheral systems or show it to the product team in order to help them identify those problems.
So it sounds like you'll try to kind of develop an expertise in the tooling that you're using and sort of the systems that you're working in, and then over time try to figure out, how do I take all of this stuff that I know and apply it so that we can address some of these reliability concerns and make this a little bit easier to maintain and something that we can rely on.
Yes.
Awesome.
Yeah.
Awesome.
Sam, do you want to be an SRE?
No, I think I'm good here. I'm pretty happy with this. But Yeah, hopefully people here are interested in becoming an SRE, or it's something that people are at least considering. With that in mind, if there are any questions, we're happy to answer them. I can bring them up and we can chat about questions. So feel free to drop a comment and we can go into those. Otherwise, we can just keep going and talking more about how awesome SREs are, because systems that are reliable and continue to work are great for everybody. I think that's one of the big things that I noticed is if your release process isn't breaking constantly, it really makes it easier to build awesome tools, right? Because you aren't rolling back changes every day. You aren't afraid to deploy on a Friday or before a weekend, or you aren't staying up over a holiday and expecting a spike. You mentioned retail and Black Friday. Like you aren't dreading those days of like, oh no, if something goes wrong, everybody's gonna like you. It gives you that peace of mind, and everybody, I think, benefits from that and gets a little bit better because of that. So
I mean, other thing is, and I mentioned this before, like any complex system is in a state of failure in some way. So you might deploy something and it might fail, but you're not concerned about it impacting your customers because you have systems that auto remediate that. Like the biggest tool for a lot of teams is Kubernetes because it auto remediates it. It restarts containers. It will move things around with a workload. And a lot of people deploy that out on top of like a data center. Like the best thing that you can do, and I mentioned this before, MDHA principles, it's multi-data center, highly available. So you have an application or a service that is in 2 data centers, and it is highly available within that data center, so that if you lose one instance in that data center, you still have an instance that's up. And it can be one or more, but following that very basic principle of having it in 2 data centers and having a service that is basically has a replica, that is the best thing that you can do. And I mean, if you can't have a HA service, meaning both of them running at the same time, the next best thing that you can do is have a cold backup kind of service where you have one that is running and you have one that would be running if this one goes down. I had a team in the past where we were not able to run the service twice. So we just had it set up that if the one went down, we spun up the other one right away and directed traffic to it. And we didn't have to worry about an outage for forever. It just automatically did it for us.
Well, and you work with Kubernetes, and I think that's one of the big advantages that Kubernetes gives you is and sort of containers, I guess, in general, where if something is failing, you have these hopefully stateless services that you can recreate if they're running into issues and they start out of memory or crashing or something happens to bring that state down. I remember when I first started engineering, there was a lot of these initial big servers where you had one VM or one server, and you really didn't want anything bad to happen to that, because if anything did, like it was the thing that ran the business. And that's sort of been, I guess, one of the changes that I've noticed over the course of my career is there's been a big difference in how we look at services and how we consider those. And I think site reliability seems to factor into that. It seems to be kind of leading that charge.
Yeah, site reliability has ruined the bring in the donuts when prod goes down, because you don't want prod to ever go down. So you don't have to bring in donuts because we try to work out ways that it will never go down. Or if it does go down, you don't know it's down because it still works.
Okay. I've only had to do that once. Awesome. I did want to, we talked a little bit about sort of the technologies that you use. Are there ways or things that you like, I guess I'll spin this in a different way. How do you go about learning new things? I guess one of the hard things with technology is it's always changing. There's always new things coming up. Kubernetes is only like 8 years old or something like that. It's a relatively new thing. Containers are not that old either. Like they're relatively new technologies, and there's constantly new things. Recently, observability or AI, which seems to be taking off, and just more and more things keep being introduced. How do you keep up to date as these patterns and technologies change and systems become more complicated as well?
Mm-hmm. I mean, so I've been doing this since I started being a programmer back in college, but I I make it a point to take at least 30 minutes a day and go through and look at all the different things that are happening out there, whether it be you're looking at like Slashdot, if you're looking at HackerRank, or not HackerRank, but what's the orange site?
Hacker News.
Hacker News, the orange site. I follow people on Twitter that are involved in the space. I have a number of books that I read, and during that 30 minutes, if I can't find anything that interests me on the news sites, I mean, I will work on something. I will implement something. I will spin up a service where I've been like, okay, this is probably a pattern where it's going to fail, or this is probably a pattern where it's going to have an issue. Let's test this out. Let's actually make this as a hypothesis. So let's spin up a service with a single queue in between it and see if I can break it by like spitting enough stuff at it that it breaks. Let's set up a multi-data center highly available service, and let's disconnect that one data center and see if I actually can handle the traffic moving back and forth with the hypothesis that I've got. It's a combination of learning by reading and following and listening, while also doing hands-on work yourself to solidify the information that you're learning. You talk about like coding boot camps or universities and such. Like, it's the same concept of like, you need to learn about the concept, you need to have that theoretical understanding, but that's not enough. You need to actually take the time to implement it yourself, to test it out, and to understand it. And that way you have a better understanding of how it all works. On top of that, being a little bit more senior in this role, like you have to explain this to people that you work with, and you have to try to help them understand it and give them as much information as you have in order to help them build it themselves or help them understand it themselves, which also helps you learn it better and helps you understand it better.
I think that's one of the things that I've learned the most. You mentioned training budgets. I guess that's sort of my term for it, where you set aside a certain amount of time in your day to focus on answering those questions that you didn't have time to previously. Whether it's what happens if I do this, or what is this new service that everybody's talking about on Twitter, or those kind of things where you actually have the time available to dig into that. It doesn't have to be a big part of your day, but it's enough to continue learning, even outside of like a formal environment where you're dedicated to learning. I think that's a really, really useful thing to have.
Yeah, I would say like if you're an engineer at any level, you should be doing that. On top of that, like taking the time to speak to like-minded individuals or speak to people in the industry, even if you're watching this video, like all of that helps you to become a better engineer. And those are the skills that you want to keep and continue working on in order to succeed over time in this career.
Well, I think that's also, as a cloud advocate, my role is largely like helping people understand tech and being able to help teach people. And I don't know a lot of all the things that I'm teaching entirely. Like that is, I think, one of the coolest things is you aren't going to know everything in tech. There's always going to be something new, and the field just moves so fast that you aren't going to keep up with it all. There's just so much going on, and so that's always really inspiring. But also being able to do that teaching part, you realize that even the things that you thought you understood, whether it's like that small little syntax thing, or how a proxy server works, or networking, or DNS, like some of those things you're like, oh yeah, this is how this works. But then you start actually talking about it, and it maybe you don't actually understand it. Maybe there's that one question that somebody asks and they're like, how does this work? And then you just shrug and you're like, I don't know, let's go find out. That's a really fun thing. And I think that's key for any role, really. But it sounds like if you're with an SRE, if you're digging into so many different technologies, being able to find people who know these different services and can kind of help you along that path and help teach that, and also being able to share what you're learning with the rest of your team or with the partner teams that you're working with seems really, really key.
Yeah, it's pretty daunting when you think about it, but I'd say like the biggest thing that will help you is like ownership of not just like the applications that you're deploying and the features that you're trying to write, but owning the full application, owning the front end, the back end, the database, the CI/CD server, the logging, the metrics, the monitoring, like taking the time to understand how all of those different components come together, not just focusing on, I want to make the best front end ever. And there's nothing wrong with that, but like, if you want to learn way more from like a broad perspective, like just understand the full ownership process of an application. If you were to write your own application for a startup and you were going to basically live off of that application and off of your user base from that application, what are all of the steps that you would need to take in order to set that up? Do you know how to set up that CI/CD pipeline? Do you know how to manage all of your logging metrics and alerting? Do you know how to set it up in a way where it will never go down so that you don't lose any money? Like these are all questions that if you don't know the answer, it'd be cool to learn it, because not just because it's cool, but it's cool to learn it because you understand way more about the entire system than you ever would.
I think that leads a little bit into my next question, which is if you're just starting out, if you're in school maybe, or considering kind of pivoting into more of an SRE role, how would you start exploring like all of these new things? You just brought up a whole slew of different things that people can take a look at, like CI/CD and monitoring and those kind of reactive learning cert things. Where do you start? Where like that's a lot.
Yeah, if you're coming out of school and you're looking to be an SRE, like the biggest thing that I'm looking for is somebody that understands not just front end, not just back end, not just data science, but like a little bit of all of it. And then they're interested in testing and checking their hypotheses with implementation of work that they're doing. Example being like, so my prior roles, I was at Target and Starbucks, and I had no thought that I was ever going to be an SRE. My only thought was, I don't want anything to go down because it really sucks to get paged at night. And when I was working on a team with some folks that were older than me at the time, I was like, man, it sucks that you're getting woken up and like you have like a wife or kids, or you have a husband and kids, and like that stinks. So like, what can we do to stop that? But because we owned all of the stuff that we were using, because we owned the CI/CD, we owned the monitoring, the logging, everything, it was a very easy question to answer of, well, let's do this. Let's put this into data centers. That way, if our pipeline ever goes down, it doesn't. What do we want to do in order to make sure that the application doesn't go down? Well, let's implement this in the application. So the biggest thing, if you're starting out and you want to be an SRE, is ownership of the things that you're actually building, full ownership, top to bottom, and then looking for that breadth of information, not just that deep down into one thing. That will help you to better understand the whole complex system and better identify how the dependencies within that system cause failure. When you add on top of that, like cloud environments where you've got multiple different services as dependencies, and those service dependencies can fail in multiple different ways because you don't own them, that's a even more complex system, and you need to understand even more to interact with that. It makes it easier because you have all these things created for you, but you need to better understand the possible failure scenarios to keep your service up.
All right, we have about 10 minutes left, so I kind of want to just grab a few key points that I kind of noticed. First one, you mentioned grid style systems. I'm unfamiliar with what that is. Can you? I know it's going back a little bit, but can you give me a little bit more background? What does that mean?
So in a grid style deployment system, and I'll explain like a normal deployment system first to give context. So in a normal deploying system, you have an application, you push a change, it goes to your CI/CD service, it may go through a battery of tests, it may go through a performance analysis, it may go through a chaos engineering analysis, and then eventually it hits your first environment, whether it be dev, stage, canary, prod, whatever. that's how the normal deployment process happens. Now, if your service is being deployed as a set of microservices, meaning you have maybe like a reading service and a writing service, and you need to deploy those in tandem in order to ensure that they will succeed successfully, or you might not need to deploy them in tandem, but you need to determine whether or not they will succeed together or fail. A great way to do that is a grid-style deployment system. A grid-style deployment system takes those two separate components. It looks at the metadata around them, the version that's been deployed, the dependencies that it's using, the region it's going out to, and it will decode that information, read it, and then compare it to the other one and know where that one's going and the version of it. And then from that, it runs the battery of tests with both of them, specifically integration testing between the two to determine whether or not they succeed together. Once that happens, it gives you the green check mark, you're good to go, and they go out together as like a pair. Now, let's say that you, Sam, are working on a project and you're pushing a change and someone else is pushing a change. It's going to validate the change that you made with two separate services and the change that your friend made or your coworker made with two different services. And then the first one that goes out there, it's going to take that one and then it's going to compare again your service and this one. And that way it can determine whether or not that next change succeeds. And that way you don't have to worry about these components being deployed different, best way to say this, different velocities, where the dependencies might mismatch or where a change might cause an issue between the two. It deploys it in more of a collective group of like the Borg. You're deploying like the Borg versus deploying like the Enterprise. You come as a big group versus the Enterprise sends one ship. The Federation sends one ship. So that's the type of deployment that I'm talking about. You're not deploying a single service. You're deploying multiple services, and they need to interact in a highly complex way. So you need to validate that before you can release it forward.
Okay, so this is similar to, I guess the most common way I've seen this is that you have a service that depends on some database schema, and you have a database schema that is getting updated. And then you need to roll out the service and the database simultaneously. Is this sort of a method of solving that problem where you don't have to just shut down things so that you can do both of those at the same time?
The common process was like you and this is what a lot of people do is you change your database schema and you have a green blue, like a database that's got all of your stuff backed up onto it, and you've got a database that is running that's there, and you may pull off the requests that are going to the current database and then switch them on later. But you need to make sure that your service works with that. So you deploy it out there and then point it at the new one, and it might break. If this were a grid deployment system, you have already mocked out what that's going to be like, and you've already tested it and gone, this schema doesn't work with this service. You can't deploy together, and it kicks both of them back. And it goes, hey, something's wrong. And the person that made the change, whether it be the schema one was the last one that made the change, it's going to kick it back to them, or whether it's the application that had the change, it's going to kick it back to them. And it's going to go, this doesn't work, you need to fix it. And that way you don't have to worry about this kind of manual intervention of green blue, like we're switching it, we did it, and then we roll back because it didn't work. You know it's going to work right away, and you do want to have kind of like a harness around it to make sure, especially with databases, that works, but it should handle it at the grid layer and give you confidence. That's what I'm trying to say.
Awesome. All right, I have one more question, and if there's anything from chat, we'll get to that. So if you have a question, leave it in the comments. Hint. But I'm curious, how do you think this role, where do you see SREs going as a role? What changes do you expect to happen over the next year or two that are going to impact how SREs do their work? You brought up AI before, and that seems like a relatively new thing. I know there's been a lot of talk about observability, maybe over the past few years. So are there other things that you kind of want to mention or think that are going to be something people might want to be interested in? Yeah.
So when I think about it, I kind of jump back to, we had like operation teams. Operation team would give you a server. That server would be maintained by the data center team. You might have a ops team that's with your application team that would handle putting the application onto the server and ensuring that it would run correctly. We've automated a lot of that. if you use Kubernetes, you know that as a fact. If you use cloud services, you know that as a fact. Like the first thing that I used was OpenStack with Kubernetes, and you see the change over time with this operation layer, because it was so expensive. It was such a manual task to like maintain these servers and update them all and handle setting up the network for them and expansion, and like sometimes you'd have pet names for regions and stuff. It's become a lot more automated, and it's become a lot more configuration based. And that's what you're going to see more with site reliability engineering in the next like 2 to 3 to even 10 years. Like the whole concept is you want to take things that you do that are manual. You want to take failure scenarios that you've identified, and you want to find ways to build services to remediate them so that you don't have to, or find ways to create guardrails for the engineering teams and the teams that are working on these applications so that they don't know that they're doing it, but they're implementing reliability by default. Like that's what you're going to see. Like it's not going to be you're implementing gating. Gating is going to be implemented by default in your pipeline. It's not going to be that you're using MDHA principles. MDHA principles are configured by default. Like when you deploy to Kubernetes, Kubernetes already has HA. Like you're moving with the workload around right away. You have replicas. Like that's the very beginning of what we're talking about here with these different advances for site reliability engineering and what you're going to see in the future. It's going to be a lot more automation around creating reliable services.
So this is similar to, I guess, the thing that I'm drawing is nodes in Kubernetes, where you really don't need to think about nodes if you're building an application on Kubernetes. There's just a Kubernetes cluster. You don't need to be aware of there are 20 nodes in this, and even if those start failing, it really shouldn't impact you. Is that sort of I guess the beginning? If
you're running a Kubernetes cluster, you shouldn't have to worry about whether or not that cluster is going to go down. It should just be up. The API server should be highly available. The nodes should be highly available within the data center. You should possibly have 2 replicas of Kubernetes just deployed by default in multiple regions. These are the types of things that you're going to see in the future, where it's not a question of will it go down? It's a question of how did you make it go down?
Awesome. I did want to leave a few minutes just for you to make any call outs. I know you have a few books. You have a blog as well. And then we've also been posting a jobs link in the chat that links to some AKS job availability. Are there any things you want to kind of call out that people might want to take a look at, or other resources that people might want to look for learning more about this?
Yeah. So if you're interested in site reliability engineering, the Site Reliability Engineering book by Google or the Site Reliability Engineering documentation on Microsoft Docs is a great place to start. I'd say the more approachable is probably the Microsoft Docs based on what I've seen. The Site Reliability book is great, but it's pretty heavy. If you're looking to follow people and get to know more about what site reliability engineers do and how you can create more reliable services, Niall Murphy, who helped with the SRE book, worked at Microsoft. He's wonderful to follow. He's on Twitter. Charity Majors is doing a ton of work in observability with her Honeycomb company. I'd say Alex Hidalgo is great for if you're trying to implement SLOs. Any of those people are great to follow. And if you're just starting out and you're looking at how you can build more reliable services, or you're an application engineer looking at how to make more reliable services, I mean, learning more about design patterns will help you, and not just application design patterns, but system design patterns will help you identify the possible failure points. And I know that Azure has a well-architected application doc on Microsoft Docs. I think that's a great place to go. Otherwise, if you're looking for jobs and you're just here watching the video, I repost jobs constantly. Connect with me on LinkedIn. I'm happy to answer questions. Otherwise, AKS is hiring. We're constantly hiring, and Azrel, my group, is hiring if you want to work with me. So,
Awesome. Thank you so much for your time. This was really, really helpful for me. I have never been an SRE, and I have never worked in it, but it's always been something that I think is important, right? You want your services to be available. And it also, I think, is important because it means failure is okay, if that makes sense. And it kind of helps you understand that you can, things are going to fail, and that's fine. And that's just a natural part of programming. And it's how at least I learn. So really big thank you for helping share your information and helping us all learn more about what this is, and hopefully inspiring some people to pursue SRE as a career. So thanks so much. And thanks everybody for watching.
Thanks for having me.
Awesome.